Following on from the previous video, we managed to work out the area of one whole petal. So the area of one whole petal here is pi over 12 in the previous video. Now we need to work out A2. A2 is this area here. So A2, rather than doing this, rather than working out this whole area, rather than working out this, well, we've got to look at this intersection of the two here, because it's summing up all the sectors like this. Hang on, you've got to take this intersection of the two here. So we are going to integrate it like this, right there. So that will then be this, and then we would need to take away. This thing here. So it's doing this. We need to take away, and remember, keep an eye out for this intersection here, and then take away this area here. Well, this area here, remember, there's a slight gap in between here. Well, so this area here is this thing here. But rather than working out the whole area, so hang on, rather than working out the whole area, which is the whole integral here, and then take away the whole integral here, what I'm saying is abandon this and use this, where you look at each individual sector and hang on, so let me illustrate this. What I'm saying here is, don't use this, use this, sum up all the sectors. So here you're summing up all the sectors, the whole thing. So hang on, let me try and explain this, sorry. So this whole thing here is saying sum up everything, and then once you've got everything, then take away you summing up everything else. What I'm saying is, this thing here is saying, remember, you're summing up all the sectors, so you've got something like this. Hang on. So let's look at this one sector here. What this is saying is, work out, just looking at this one sector only, work out this whole thing here. So that's this thing here, and then take away this thing here, only for that one sector. And then once you've got that, then sum up everything. So there is a slight difference. Here is saying sum up everything first, and then sum up everything here. And then once you've got the whole lot, then get that one thing, take away the other. What this is saying is sum up. What this is saying, look at each individual sector. So let's look at this one sector here. So this thing here is saying, look at this one sector here, and then get one, take away the other. So get this long thing here, take away this thing here. So that will then give us this small bit here, and then once you've got that small bit, then slowly sum up everything else. So slowly sum up everything else. So I hope you can see the difference. Anyway, we are currently here. So remember, we are just looking at the top half. This thing here. So to get the whole A2, you would need to times it by 2. But we need to integrate it from 0 to where. We need to figure out this where. Well, that where is the intersection of the two. It's this bit here. Because you need to sum up everything like this. You're summing up everything like this. You're summing up everything like this. And then when do you stop? You stop when there's an intersection here. When the radius is a half, that's when you stop. So we need to figure out, we got to integrate it from 0 to where. We need to figure out this where. Well, this where occurs when the radius is a half. So the intersection occurs when theta equals pi over 9. So I'm just going to skip this bit. It would be pi over 9. So we need to integrate it from 0 to pi over 9. So that will then take us to here. So A2 is given by that, and then times top and bottom here by 2. That will then take us to here. Factor out the quarter, so that will then take us to here, and then merge these two together. That will then give us 1, and then integrate. So integrate this, that will give you theta. Integrate this, that will then give you this, and then put pi over 9 into here, and put pi over 9 into here. So hang on, let's start again. If you put pi over 9 into here, that will then give you this. Put pi over 9 into here, that will then give you this thing here. And then if you put 0 into here, it would be 0. Put 0 into here, the whole thing would be 0. So that will then take us to here. So what is this block here? So to work out that block, look at your circle. Look at your circle. The angle 2 pi over 3. The angle 2 pi over 3 is right here. So when you're talking about sine, you are talking about the height. Well, if you're talking about the height, then that's the same as this height here. So I'm gonna imagine this to be a equilateral triangle of 2, 2, 2. Cut it down the middle. It will be 1, 2. If this is 1 and this is 2, this must be root 3. Well, the height, because we're talking about sine, this height here is actually root 3 over 2. It's actually root 3 over 2. So this block here is this thing here, and you've got your 3 down here. So tidy this whole thing up. That will then give you this thing here, and then so A2 equals this thing here. So let me reiterate. A1, which is the whole petal, is given by pi over 12 in the previous video. A2 is A2. What's A2? Hang on, let me think. A2 is this thing here. So A2 is this thing here. Tidy up, and hang on, let me think. Have I made a mistake somewhere? Oh, there should be brackets here. There should be brackets here, because this is A2. So that would mean minus this. That will then give you this, and then minus this. That will then give you this thing here. So sorry, I made a mistake here. There should be brackets here. Okay, and then it's blah blah blah, and then it will give you this. So the whole area is equal to this thing here. Even though there's brackets here, this is correct. This is correct. Okay.